Hello students, this is 20th lecture in succession of vector calculus. In this lecture, we'll discuss divergence of a vector point function and curl of vector point function. In the previous two lectures, we have discussed gradient of a scalar point function and problems and solved problem based on that. Now, let us see what is the divergence of a vector point function. Let f be any vector point function which is differentiable, then the divergence of this vector point function f is written in small div of vector f is defined as divergence of f vector is equal to del dot f vector. Del, substitute the value of del here, dot f. So dot this is vector, f is a vector. So uh, we have the if we operate this del, we find the dot product of del with f will get this is equal to iota dot partial derivative of f vector which is 2x plus j dot partial derivative f is to y plus k dot partial to z. Now, if f is given in component forms in this three-dimensional coordinate system, then divergence of f is given by divergence is given by iota dot partial derivative f vector components of vector with squares plus j dot positive components of f with 2 y vector plus k dot positive f vector with this to z component z coordinate z coordinate. Now, if we simplify them, simplification means I dot I is equal to 1, other I dot j is equal to 0, I dot k is equal to 0. So that from the first dot product we get positive f is to x. Similarly, from the second component we get positive f is to y upon f2 is to y, f2 this will be j dot I 0, j dot j is equal to 1 and j dot k is equal to 0. So we got positive f2 is to y plus positive f3 from third component. Third this term we got positive f3 is to z. Now, if we find from this we can conclude that if you find divergence of a vector point function, your the resultant will be a scalar point function. Scalar point function. Now, another definition: solenoidal vectors. A vector point function f is said to be solenoidal if divergence of that vector comes out to be zero. If the divergence of any vector point function is zero, then that is called a solenoidal vector. Now let us discuss the what is the physical interpretation of this divergence. Divergence. Now for that, draw a small parallelepiped with edges del x, del y, del z parallel to the axis in a mass of fluid. Mass of fluid, fluid which is moving in one direction. With one of the corner at H, diagram shown in the diagram, let v is the velocity of the fluid and the components of velocity in the along the three uh, axes are vx along x-axis, vy along y-axis, and vz. Therefore, v will be equal to vf is equal to of the v is the velocity of the fluid. V f is equal to vx iota vy j plus vz is component velocity. V the velocity of the fluid at h. At the diagram is called h. At h velocity is now the amount of fluid entering the face, this face A B C A B C H, the face ABC is equal to velocity parallel to x-axis Vx into this area, del x into del z into del x, del z into del x. Amount of fluid entering the face, this face is equal to area into component velocity. The amount of fluid leaving the face, uh, FEDG, FEDG, F, FEDG, this phase will be, now this fluid is very small because its length, breadth, and height are del x, del y, del z, del is very small. So the amount of fluid which can velocity at this distance, the velocity leaving the phase will be v of x plus del x. So v of del x plus del x, velocity at this phase velocity, and the area of this will be del y, del z into del y. So this is the amount of fluid leaving the phase, FEDG, in unit time. Now the v is the velocity at the phase, ABCH, and v of x plus del x is the velocity at the phase, FEDG. Therefore, uh, this velocity will be equal to the total derivative of v at this phase. Vx plus also vx is to x dx del x del y del y. Now the net loss of amount of fluid due to flow across the two phases. If fluid enter this phase and leave this phase, the, the net amount of the loss of the fluid due to flow between these two phases will be given by per unit volume. Volume will be this is equivalent, and volume will be given by this minus leaving minus entering. Leaving minus entering, Vx from will go, and we are left with positive Vx, Lx, then the del. This is volume. The net loss of amount of fluid due to the flow across the two phases per unit volume. Similarly, for the other two phases will be how much? If the fluid enters along y-axis Vy, and that's Vy plus V of y plus del y. So similarly, the net amount of loss of uh, fluid across the other two phases, this phase A, H, E, F, and B, G, C, D will be equal to partiality of Vy is to y, del x, del y, del z, and similarly on the fluid entering this phase A, F, G, B entering this phase and leaving this phase. Current volume, this volume will be partiality of Vz is to z, Vx, Vy. So when we add the these three components loss, this loss of fluid, loss of the amount of fluid, will get the total loss. Total loss of amount of fluid due to the flow along all the phases per unit will be sum of the three. Three will be positive v is to x plus positive v is to y plus positive v is to z per volume del x del y. Now the rate of loss of fluid per unit volume. If we divide this total loss by the total volume through which this fluid entered and leave the faces will be equal to partiality of v is to x and del vec del volume per liquid. They cancel out, and this will give the divergence of v. Divergence of v. So divergence of v is the rate of loss of fluid per unit volume. That will be that we will get from if we velocity of fluid, partial of v component of velocity along x-axis is to x, partial component of velocity along y-axis is to y, plus partial derivative of component velocity along the z-axis is to z. Same definition of vector. Therefore, divergence is the rate at which fluid is issuing at the point per unit volume. So at, we are discussing at the point H. So this is the divergence of V will be is the rate at which the fluid is issuing at the point per unit volume. Now solenoidal vector. function. If divergence of v is equal to 0, what is the meaning of this? If divergence of v is equal to 0, the flux means entering and leaving. The flux entering any element. What does it mean? What does this mean? What does this mean? This means the flux entering any element of phase of the same is the same as that leaving it everywhere. क्या बोलते हैं? If the solenoidal vector function which function is solenoidal vector function, if divergence of is equal to 0, that is, what's the meaning of this? This is the flux entering any point of space is the same as that leaving it everywhere, then such a point function is called a solenoidal vector function. Let's discuss what is curl of vector function. So again, we are given f is a vector function. Let f be a differentiable vector function and which is differentiable, then curl of f is defined as del cross f. Del of f is is called divergence of f, and del cross f is the vector. It's also is a curl of f. Now del substitute del cross del. Again same as it in the this in case of dot product, we have cross product. So we operate this del on f vector with cross product. So cross product will be using vectors. So this is the iota cross product of f is 2x, g का cross product of f is 2y equals vector. Cross and dot then we must have the proof for that. We have, every time when we solve the problem, we have to decide when we are finding the cross product, we have to find in the vectors only. K vector cross positive f is 2. Now curl of f is also known as the rotation of f. Curl means curl gives us the rotation. Now component form, let f is in component form. Then curl of f in component form will be given by, now operate substitute f iota cross positive f vector is to x component plus j cross positive f vector with y is to y plus k cross. Now we know that I cross I is equal to 0, I cross j is equal to k, and I cross k is equal to minus k. So similarly, j cross I is equal to minus k, j cross j is equal to 0, j cross k is equal to I. Similarly, k cross I is equal to j, and k cross j is equal to minus I, and k cross k is equal to 0. Substitute them, and we got these expressions. This expression can be converted now in the terms separately components and the x component, y component, and z in terms of x, y, z components. Now this can be converted to determinate form. So in order to remember it, curl of f vector is equal to curl of f vector is equal to how much? Is equal to ijk. Ijk is equal to positive f is to x, positive f positive is to y, positive z, fx, fy, fx. Now if you put this determinant, it is the outcome of it. Now irrotational vector. Curl of f is also called the rotational vector. So when will we say that this the vector point function is a irrotational vector function? A vector point function f vector, vector function f vector is said to be irrotational vector if and only if curl of f is equal to 0. Curl of any vector point function 0 means that is a irrotational vector function. Now let's discuss the physical interpretation of the curl. Now again, let v be the velocity of a particle of a rigid body. Rigid body, because the fluid conductivity on the body conducted will be rigid body, whose angular velocity is here. Let v is the velocity of the particle of the rigid body, whose velocity and velocity is here. Then curl of v vector is equal to 2 v vectors. Prove it. Prove is, let r is the position to any point, any vector point function of any position of vector point function of a particle whose velocity is v. Let r is equal to, in component form, this in component form, be the position vector of the particle whose velocity is v. Therefore, we know that velocity is equal to angular velocity cross roughly the position vector. Okay, we want to find that in any point. So curl of, therefore, velocity is equal to angular velocity cross product with position vector point on the equation. So curl of v vector is equal to curl of this. Curl, substitute the curl of this. Curl now again interpret it. This is equal to iota. Now is a constant. That will this is equal to iota cross positive of this is, and then the constant is 0. Therefore, we don't use the product here. This will cross iota cross a vector cross positive of r to x. Plus similarly j cross a vector constant cross positive of r to y plus a cross positive of r. Now let's find positive r. This is y. Now r vector is this. X iota is y to z. A positive r is to x is equal to iota. Positive r is to y is equal to j. Positive r is to z is equal to k. Now substitute their values. Value of positive r square, positive r is equal to z. Therefore, curl of v is equal to iota cross a vector cross I plus j cross a vector cross I plus k cross a vector cross k. Now we use here the method cross product three vectors a cross b cross c will be equal to a b minus c, a cross a dot c b vector minus a b c, b minus c. We will use this step, this and this also. So when we use the cross product three vectors in these three terms one by one, we get is equal to a vector minus iota, iota into iota vector, and iota into a vector. Similarly, uh, a vector minus j vector, j cross j dot j minus component will be j dot a. And third will be similarly a vector minus a vector is equal to k vector dot k vector minus k vector dot k. Now I dot I is equal to 1 and j dot is equal to 1 and k dot is equal to 1. This will be dot a vector, a vector, 0. Now if we find the dot product a vector with a, dot product with a, we get x component vector. Suppose this vector has three components. So a has three components. Iota is equal to iota dot a is equal to a iota ax iota plus ayj plus azk is equal to I dot I is equal to 1. So this is going to be ax. I dot j is 0. I dot j is 0. So this will do ax. Similarly here, j dot a vector is equal to ay and k dot a vector is equal to ak, and this will become a vector. This will be 3 vector minus 0 to 2. So if you find cross product So curl of any curl of velocity of particle of this body will have that will be twice of the angular velocity. And this is called dV. Now, what is negation? Del square. Okay, del square. How will you get del dot del? Equal to percentage. And the del means alpha plus x plus j versus y plus k versus z dot alpha versus x plus j versus y plus k versus z is multiply them alpha by j is one otherwise not zero. Therefore, it will be del square will be equal to partial second over this x plus second over y plus second over z is called next. Now let's compare the difference between del upon which function del operate and del square. That is operate and del and del. It operates on scale function. Gradient del operates on scale function and this del of phi scale function is equal to gradient. If you find the dot product of this gradient, the del with the vector function, you get divergence of it. If you find a cross product of this gradient or del with the vector function, you get the curve. Uh, it operates on both scale function. Okay, notice that it operates both on scale function like the let's say del is equal to if you create the gradient, if you find the del of any scale function, that is already vector. And if del dot f vector comes out to zero means gradient of a vector point function comes zero, that is solenoidal. If the gradient the curl of vector any vector comes out zero, that is irrotational. Del square is a scalar point, scalar actually scalar vector. If any function satisfies the equation del square of f is equal to 0, then that is called harmonic function. That's called harmonic function.